Saxon Algebra 2, Lesson 98. I don't like the name of this lesson. Relationships of numbers. What does that even mean? But I can't think of a better name, so we're just going to call it that. This is a very specific type of calculation that is fun and easy once you get the gist of it. Here's what's happening. Imagine a number line. Imagine that there's a number here. We're going to call it S, and that stands for the smaller number. And there's another number down here. We're going to call that L. That's the larger number. Notice that on a number line, smaller numbers are always to this side and larger numbers are to that side, right? That's just how number lines work. Now, what we want to do is find the number that is some fraction of the way from the smaller to the larger. So I'm going to show you. There's a very specific formula that we use. This distance, I think you will agree with me, we could describe as the larger number minus the smaller number, right? That's an S, not a 5, right? If we want to find this distance, like say this is number 2 and this is number 5, you just 5 minus 2, it's 3 units in between, right? So we can easily calculate the distance in between the two numbers. F stands for a fraction, some fraction of the way. What number is 2/3 between 2 and 5 is what I said, right? Here is the little formula that we use. We take the smaller number and we add the fraction times the distance in between. That's an L, not an F, sorry. All right? So we say take the fraction and multiply it by this distance and then add that onto the smaller number. This is the formula that we will use to solve these problems. Let's do an example that's got really super easy numbers, and that will help you see how this is all working. And then we'll use some more obscure numbers where you just have to trust your calculation. We're supposed to find the number that is 7/10 of the way from 30 to 40. Ignore that line. Okay, what number is 7/10 of the way from 30 to 40? All right, so let's set up a picture like this one. Here's our number line. Our smaller number is 30. Our larger number is 40. And we want to find the total distance from here to there. And we know that we can find it, we can just look at it and figure it out. It's 40 minus 30 equals 10. Okay, so there's 10 units from here to there. All right, that makes perfect sense, right? 40 minus 30 is 10. Now, we want to find the number that's 7/10 of the way. Now, if your brain is working like my brain, this is what my brain is seeing. My brain is saying, okay, you could make the number line. See if I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, my brain automatically visualizes the little hashes in between 30 and 40, and I know there are 10 of them, right? 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. There's 10 of them. If I need to go 7/10, that means I do 7 of them. 1, 2, 3, 4, 5, 6, 7. Wait, now I forgot. Oh, it's right here, right? And that gets me right there to the number 37. And that is the answer. That's the right answer. It's easy to visualize because we know there are 10 units between 30 and 40, and we're supposed to go 7/10 of those units. Well, the denominator matches exactly to how many there are, so it's super easy to visualize that this is the right answer. That will not be true of every problem. The numbers get weird. But now let's try using our formula and see if it works the same way. Using the formula, S plus F times L minus S. The smaller number is 30. The larger number is 40. The fraction is 7/10. All right, so let's try plugging in. 30 plus 7/10 times 40 minus 30. Oops, I forgot the 0. Okay, this is using the formula to solve it. 40 minus 30 is 10. This 10's in the numerator, this is in the denominator. Those cancel. 30 plus 7 equals 37. Okay, so what we see is that the formula works. This is the way we can visualize it when the numbers are easy. The next one, the numbers are not going to be so easy to visualize, so we won't draw this picture, but we will trust the formula to work for us, and it will always work. All right, so let's try the next one. There are 3 examples in this lesson. Ready? 98.2. Find the number that is 1/5 of the way from 1/8 to 9/11. The numbers are not so cute, are they? But we can quickly identify which one's which. Now, it's confusing because they're all fractions, and last time we only had 1 fraction. But when we see the from and to, we know that this is smaller and this is larger. John will always give them to us in that order. Pretty sure he does. And so that means this has to be the fraction. 1/5 of the way is the way it's written in the problem. I didn't copy that down. So using our formula, S plus, right? That will give us the answer, that in-between point we're looking for. So now all we have to do is plug in. 1/8 plus 1/5. This is a 5. That is an S. Boy, it's confusing, isn't it? Times 9/11 minus 1/8. That's how I plug in the numbers, right? And if it helps you, we can visualize it without even necessarily putting all the numbers in. We know that here's our smaller number, here's our larger number. The difference between the two is L minus S, and we multiply that times the fraction, and it will take us part of the way. This isn't necessarily proportional, right? This is the fraction times the difference, and then we add that to this in order to find the number. So we can visualize it if we want, but it's not necessary to draw a graph. All right, the hardest part of these problems is just managing all of these crazy numbers. We want to start here in the parentheses. We want to actually do this subtraction. We're going to have to multiply this one by 8/8 and this one by 11/11, right? In order to get the fractions to combine. So this then will become 72/88 minus 11/88, and that equals 61/88. Okay, so let's put this back in for this. 1/8 plus 1/5 times 61/88. All right, that's a big multiplication, isn't it? But we can do it. That's going to equal 1/8 plus, and we multiply 61/440. Ay, ay, ay. Now we have to make this denominator match to this. How many times does 8 go into 440? Well, this helps me figure that out because I know that 5 times 88 equals 440, right? So then I can change it. It's 5 times 8 times 11 equals 440, right? I just blow that 80 out so that the 88 into 8 times 11, that works. I already have the 8. That means 8 times 55 also equals 440, right? I take the 8 over here, and then I combine the 5 and 11 to get this 55. That's how my brain manipulates these numbers, so I know what I need to multiply this fraction by in order to get the 440 on the bottom. I could have just done long division, but my brain did all of this, just looking at this and then comparing it to this. I go, oh look, 5 times 8 times 11, this is the 8, so 5 times 11, multiply top and bottom by 55. All right? And then my brain says, okay, you're now 55 over 440 plus 61 over 440 equals 116 over 440. Huh. All right. Well, I'm pretty sure that we can break this down, right? I can take some numbers out of this. I know I can take 4 out because 100 is 4 divided by 25. And this, I know 4 is going to go into that cleanly. So let's divide this by 4 over 4. 4 goes 25 times into 100, plus 4 more into 16. So this tells me this is 29. If you are not helped by me talking through some of these things, just divide them out yourself and ignore me, all right? My mom used to do this to me all the time. She would try to like word explain, and I'm like, I have no idea what you're talking about. Do whatever works for you. I'm trying to help you see some of the little like mental gymnastics you can do so that you don't always have to do long division, but there is no shame in doing long division. That's the final answer. 29 over 110. Yay! All right, so the formula works even when the numbers are wicked. Let's do one more. Find the number that is 2/3 of the way from 2 1/4 to 3 5/6. All right. You know what I'm thinking. I'm thinking mixed numbers, get out of my life. I don't want you here. John tolerates those mixed numbers. He works with the mixed numbers. So if you like mixed numbers and you want to work with them, you can look in the book and do it his way. Well, no, he changes them pretty quickly too as well. I don't want anything to do with these. I'm changing them immediately to impropers. 18, 23 over 6. Remember, it's bottom times the big plus the top. 18 plus 5 is 23. 8 plus 1 is 9. Denominator stays the same. So this is my fraction. This is my smaller, and this is my larger. My expression, my formula is smaller, plus the fraction times the difference, like so. So let's plug in 9 over 4 plus 2/3 times the larger 23 over 6 minus 9 over 4. Plugging in is painless. It's dealing with all these redonkulous fraction-y fractions that makes us cry a little. Okay. Least common multiple, 24, right? No, it's 12. I don't have to go all the way up to 24. We can just keep it at 12. So let's fix these two so we can do this subtraction, right? We do the subtraction first because it's in the parentheses. Then we do the multiplication. Then we add. Order of operations at its finest. This one we better multiply by 2 over 2. And this one's 3 over 3. So we get 46 over 12 minus 27 over 12, and that equals 19 over 12. Okay, this now goes in here. Let's rewrite the whole puppy. 19 over 12. Okay, that looks good. This we're going to multiply. That's easy, but hey, we might as well break this down if we can, right? So this now equals 19 over 18. Oh, all right. So now we have 9 over 4 plus 19 over 18. We have to make these denominators match. Least common multiple here is 4 does not go into 18. So let's double 18 and see if 4 goes into that. That would be 36. Yes, 9 goes into 36. So there, we'll deal with that. This will multiply, it's 9 over 9, and this is 2 over 2, right? 36, 36. So now we have to multiply the tops. 9 times 9 is 81 over 36 plus, that's 38 over 26 equals 119 over, oh, I'm sorry, I wrote 26, it should have been 36. I calculated it correctly, I just wrote the wrong number. 119 over 36, and that is the answer. 119 is prime, so even though 36 has lots of lovely factors, there's nothing we can do. That's our final answer. All right, this is kind of a throwback with all of this fraction work and least common multiples. We haven't looked at that too much in a while, but it's really good practice to refresh your memory. All right, that is the end of good old lesson 98. And I will see you next time.